Hey everybody, MS Farzan here, and today we're going to look at a 2D multiplayer card game template using Godot and Colyseus for the backend multiplayer aspect. If you've been following my channel for a while, you might have seen some time ago I put together a handful of templates using Colyseus as the backend for 2D multiplayer games, whether you're using Unity and C# or Phaser and JavaScript or Defold and Lua for the front end, the clients. And I suspect there might be some people out there who would prefer to use Godot instead of any of the other engines or frameworks that I mentioned, and it's become quite popular. So I've taken a crack at making a similar template for Godot, given that I've been using Godot for a couple of different smaller projects for my own games that are not multiplayer. They're just for single player usage with my role-playing games. And so I went ahead and used Colyseus for the backend for this project, and all of the code is available on the same repo that contains the templates for the other game engines that I mentioned, which I'll share in the description of this video. There are a few other things that are necessary to get this up and running, but let's just take a look at what it looks like and what you'd be using out of the box. So I have here two windows open that I'll switch between, and I have a server running in the background just locally. And as you'll see, there is a player area down here, like where my area would be to play my cards. There's an opponent area up here up top where other cards are going to appear. And there's a simple drop zone in the middle where we're going to drop our cards. And I'm going to walk you through how the project works with all these things and a little bit of the code as well. So when I hit draw cards, it's going to draw 5 cards here in my player area. These are just simple panels that I've created in Godot. You could just as easily use sprites as I've used in the previous projects that I mentioned, and all of these say front. Now if I go to the other project, or the other open window, you'll see that it has loaded 5 of the cards in the opponent area for this second client, and these all say back, just to signify that these are the backs of the cards that were displayed. So like if I dealt myself 5 cards, they would be face up for me, but they'd be face down for you. Now the same thing happens when I draw cards here on client B. If I go back to client A, now there are 5 cards that have been drawn, and that's signified. This may seem really simple, but actually what's happening is it's sending a message to the server, letting the server know that these cards have been drawn, and then it's rendering what's happened on the respective client. Similarly, when I drag a card from here, from my player hand as it were, and I drop it, it's going to collide with the drop zone, and it's going to fall right into the drop zone. That's going to appear on client B as that not only has one card been played here, but also it deletes or removes one of the backs of the cards, so we know that a card has been played. And if I do the same on client B and go to client A, it nicely renders that a card has been dropped here, as well as deletes one of the card backs, and it moves in a sequential order, so there's a little bit of space between each card. So just like that, and I see that the same thing is happening on the opposite end. And just a helpful piece here, if I drag and I don't drop it in the drop zone, so there's no collision with the drop zone, it'll just go back to where it came from, back to the player area. That's basically the feature set of this little template, and you can use it to build pretty much any type of card game. Certainly you might have way different functionality than what's necessary here, but the important thing is using Godot as the rendering for the different clients, and then the servers being handled by Colyseus, similar to the other projects. And if you haven't checked those out, I have a video about that too, so you can if you prefer to use a different game engine, you can see if one of those will do the work for you. Now let's get into how this works and why. So The basic project is using Godot 3.5. I'm not using Godot 4 because I'm not really sure what the status is just yet of its viability for new projects. I know even the developers are encouraging you to use more stable versions of Godot for, if you're working on a long-term project. But so this is Godot 3.5. You may notice that the theme is a bit different because I'm using, I've adapted a theme for Godot 3.5 that was made by Azagaya. It's called a pixel art sci-fi theme for Godot. And I've made some modifications so it looks a bit more cyberpunk for my needs, for my types of games. And then there are two other packages, so you don't need to use that certainly, although it's included with the repo. There are two other packages that are required to make this work in the way that we want it to. If I go to my project settings, we can take a look at them. Under plugins, I'm using the Godot Colyseus plugin, which is I'll include in the description for the video. Colyseus has several official clients, mainly Unity, just plain old JavaScript or TypeScript, Default. I think there's one for maybe like a C++ one, and also maybe a Hacks one. Don't remember the specifics, but it's not so important here. The point is that the Godot support for Colyseus isn't official. It's made by one of the community members or a community team, but it still seems to work, at least for my purposes. And the second thing that I'm working with here is called multi-run. This allows me to, instead of just having one client run, have two clients run at once so that I can easily test the scenario of having multiple players playing the game at the same time, which is very important for me. And so those are kind of like the prerequisites here. And let's actually just start by looking at the backend before I talk about the Godot part of the project, simply because it's what's common between all of the different templates that I've shared previously. It's very similar. I've made a few modifications, and the structure of it is this server folder. And in the server folder, there's a source folder which has rooms and schema. The entry point is this index.js, which you really won't need to mess with very much. And then you'll see game.js is the main room where most of the action happens on the Colyseus end. This version of Colyseus, or this using the SDK that comes with Godot, requires you to set up a schema. Schema is a way for you to set up certain things regarding your game state that you want to be tracked. I don't really use them very much for anything. I just have a very basic game state schema that keeps track of a synchronized property, which is the string hello world. So basically, I'm keeping this as simple as I can. The game.js room, which is the main point where we're going to have a lot of action happening, supports I've had it support only 2 clients to connect, and when a game room is created, I want it to log to the console that that's happened, and also surface the room ID so that, let's say you want to get players to join a specific room, well, you can do that by using the room ID. And then I've set up a series of messages, like if there are server messages, I want Colyseus to broadcast those server messages to the client. Or if there's a game message, I want it to broadcast to everyone except for the client. So like the client that is has sent that game message. So when I, for example, drop a card, I want the client to let the server know that on the client side I dropped a card, and then I want the server to let all other clients know, in this case it's only the second client, that a card was dropped, and then that client can handle rendering of what happened, rather than me saying, okay, I dropped a card, and then the server tells all clients, including me, that a card was dropped, and then I've basically duplicated the card drop action on my the rendering side of things. And then I've also set up a client request. So This is basically the beginnings of trying to help prevent against cheating. So as we'll see when we walk through the client side of things, when I want to draw cards, the first thing that's going to happen is not the rendering of the cards themselves. I'm actually going, as a client, I'm going to send a request to the server to say, hey, I'd like to draw cards. Then here is when you determine as the server, is it appropriate for that to happen right now? And then I can then send back the request and say, okay, yeah, go ahead, draw the cards. I haven't really messed with it here, but this is the architecture of how I would handle it if I were to do so. And then there are a couple of just callbacks when a client joins or leaves, or when the room is disposed, just log to the console what happened, or broadcast it to the clients. And we can see the server that's running right now. We can see this actually happening in action. It's listening on port 2567. When the clients joined the server, a game room was created before the start of the video. And it surfaced the room ID for our use, and then it said, it gave the IDs of the clients that joined, and then also when they left and the room was disposed. That's pretty much the extent of the server. There are obviously much more detailed notes that you'll find by working through the code. And then let's take a look at the Godot aspect of things. So also pretty simple what we have here. Oh, and you can also see in the logs here from the game that we just played what the messages were, that cards were drawn or that card was dropped, etc. So on the surface, it's pretty simple what we're going to do here. On the kind of like the meta angle, it's a little bit monstrous because we're using 3 different coding languages. Here, we're using GDScript for the client because that's just the way that the client SDK for Godot Colyseus works. I think you're not able to like inherit Godot classes in C# or something like that. So like basically I tried to do everything in C#, but it just wasn't possible. I prefer to use C# with Godot and just in general. So the actual game scripts are written in C#, but we have this one client script that is in GDScript. So we have GDScript for the client side, C# for the game scripts, and then we have the JavaScript or TypeScript if you prefer on the back end for Colyseus. So it's kind of monstrous, but anyway. The user interface stuff, that's probably the easiest stuff to wrap your head around, is the opponent zone up top. This is just a pretty simple panel, but it looks kind of nice and spiffy because of the theme that I used, and also made edits to, so it looks this way. There's also the player zone down here, which is also just a panel. We've got a button which says draw cards, and then we also have a drop zone, and attached to the drop zone is an area 2D, which is required to have a collision shape 2D, or a collider, that this is going to collide with our cards. The way this is worked out is that it's on layer 1 and the mask is 2, which is flipped for the cards, which means that the cards will collide with the drop zone and vice versa, but they will not collide with each other or with other things. That's the functionality we want to have. We want to use here. I also have a basic game object for our client and a game manager here. Now, let's see. Other things to note. In terms of the cards, there's no card in the scene yet because we want them to be rendered after the draw cards button is clicked. So what we have is just a little card scene here. Like I said, I've used a panel here because I like the way that they look, and then I can add a label to write on them, but you could use sprites instead. There's no problem with that. And then an area 2D, which is similar to the area 2D and the collider that we have attached to the drop zone, but the layer and masks are switched so that they collide with one another. And then a basic dummy card back, which doesn't have the area 2D or the collider because I'm not going to be able to move them around or do anything. The card also has a script attached, which we'll take a look at, which is the drag script. And then if we go back to the main scene, the client and the game manager both have scripts attached to them, which are the GDScript and the C# script that I mentioned. We'll take a look at in a moment. The only other thing that I want to point out here, because it's kind of buried if you're not looking for it, is on the client side, if we go to the node area, there are several different signals that are attached. So, and that's when, when we look at the code, we'll see the draw card signal, drop card signal, and render card signal. This means that the client has received information from the server, and it's propagating these signals that are attached to similar functions or methods in the game manager script to let the game manager to handle the drawing of cards, rendering drop cards, or rendering cards. Signals are a way by which Godot handles decoupling scripts and game objects from one another. So you could handle this in a different way. The reason why I'm doing it this way is, like, let's say you had a different script that you wanted to change, or you wanted to make some changes to the game manager script or whatever. This is an easy way of doing it without having your code so tightly coupled that everything depends on one another. It's kind of like the client is just sending out a signal into the universe, and then you get to decide how to handle that on the client side of things. And if you make changes to it, it's not so onerous. Similarly, the button has a built-in signal. When the button's down, it is sending out a signal which is going to go to the client that the button was pressed. And the game manager has signals that when a card is dropped, it wants to let the client know that, so the client can send that information to the server. And when cards are drawn, it will send a client that information as well to send to the server. Finally, if we go back to the card scene, it too has a couple of signals, built-in signals when the mouse has entered the space and when the mouse has exited, so we can work on our drag and drop functionality there. And then the Area 2D collider, and this is the same for any collider that you use. You probably use when on Area 2D entered or on Area 2D exited. This means when it collides with something, do something. When it stops colliding, do another thing. And that collision in our game is only happening with this drop zone here. Cool. So why don't we start with the client script? This is client.gd, and I don't know if you can see this. Oh, I'm zooming in so you can see it better. So this is a basic adjustment of what's included with the Godot Colyseus package. We're loading the Colyseus.gd, the basic client SDK, and we're creating a variable called room, which is derives from Colyseus.room. We just set up this basic schema that we don't ever really use, but it seems to be required just for the thing to function. And then under the ready function, which happens when this game object, the client object, is first instantiated, we're going to create a new client listening on the port 2567. We want to join the room called game using the game state that we created. And if it doesn't work, let us know. And then we also want to signify that when we receive a server message, we want to use the onServerMessage function down below, which I'll show you. Same thing for a game message or a client request. And then we're going to set up the three basic signals to draw cards. When we receive that information from the server, we want the game manager to do that, or however you're going to handle it. Same to render cards or when a card has been dropped. And so when we receive a server message, just print the data that is attached to it. When we receive a game message, also print the data, but if the data was that cards were drawn, let the game manager or whosoever know through our signal to render cards. Or if a card was dropped, let the game manager know that a card was dropped. Then the game manager should handle it. When we have a client request, print the kind of request it is, and if the client request is to draw cards, well then go ahead and draw cards. I'll show you how this works in a moment with the game manager. Now, when we have three functions that are receiving functions, receiving signals from other places. So when the button is clicked to draw cards, that's attached to, that sends a signal that we're receiving here in the client to send to the server this client request to draw cards. And that's what initiates the whole process for the server, then say, okay, send us a message that says this client request that says draw cards, and then we're going to emit the signal to the game manager to actually handle that. If cards, now after that happens and cards have been drawn by the game manager or rendered, we're going to send a game message to the server that cards have been drawn, and then have the other client handle that. When we've dropped a card, we're also going to send that message to the server to let the other client know that such a thing has happened. Cool. So that's it for the client script for now. I'm going to switch over to Visual Studio, although we can look at the well, we might as well just look at everything here, right? I'm working in Visual Studio for the drag and the game manager scripts because I prefer that, but who cares? Let's just look at the game manager first. We've exposed a card scene and a card back scene here, so that, let's see, on the game manager side of things, so that we can just drag and drop the card scene and card back scene right here. So it knows what game objects to instantiate at the appropriate time. And then we're going to keep track of the number of cards in the drop zone so that we can render them from left to right and not on top of one another. And we're also going to keep a list of the number of opponent cards or the card backs so that we can delete them or remove them one by one as they're played. We start with the cards in drop zone being 0. And then when we receive a message that we want to draw cards from the client, essentially that the server has said it's okay for us to do so, we're going to instance 5 new panels or 5 cards, and we're going to render them sequentially on our the player hand or the player area, and add them as children of the game manager so that they are rendered on screen. And then we'll emit a signal that cards are drawn, which then goes back to the client, which lets the server know so that the other client can handle rendering them in the opponent area. And when the client receives that information, the second client receives that information to render cards, it will then waterfall that information to the game manager, which will then render the cards in the opponent area. Similarly, if a card is dropped, like here, let's say we drop a card in the drop zone, we're going to increment the number of cards in the drop zone so that we know to move from left to right. And we'll say, hey, client, a card was dropped. The client will let the server know. And the server will come back to the other client, the client in which a card was not dropped, and the game manager will receive that signal and render a dropped card, so that your client and my client are both in sync. And then I've just created 2 basic signals, which is that cards were drawn or a card was dropped. And finally, the drag script. We're keeping track of whether a mouse has the mouse is over this panel or this card, whether or not this card is dragging, if it's over the drop zone, what the start position is, and we also want to store the game manager, which is the parent of this this card as they're being instanced. And so if the just moving to the bottom of the script, when we have a signal that the mouse is entered the space, we'll say the mouse is in. When the mouse is exited the space, we'll say the mouse is out. On area entered is when a collision happens, and because there are only 2 colliders in this game, we're saying that when a collision happens, it's over the drop zone. When a collision stops, it's not over the drop zone anymore. And so if the mouse is in, meaning over the card, and in terms of the input, someone is clicking the left mouse button, we're saying the card is being dragged, and we're going to move the card along what the mouse is doing. And we're also, this is important too, we're going to move this, we're going to move the card to a place closest to where our eyeballs are. So if we didn't do this part, this little piece, what would happen is the card might move around, but it's going to move around behind other cards or behind the user interface, however you've set up this hierarchy here. Instead, it sets it, I think it's the lowest thing on the hierarchy is the closest thing to your eyeballs. And so it moves it to the lowest. So like if there are 5 cards underneath the game manager here that are nested under the game manager as children, it's going to move it to the bottom, which means it's going to be closest to our eyeballs. That's very important to make sure your card stays above everything else in the scene. Now, when we let go of the left click button, we're saying it's not dragging over more. If it's over the drop zone, which means that it's colliding with the drop zone, then drop it on the drop zone based on the number of cards in the drop zone from left to right, and let the game manager know that we've dropped the card. And then we'll see, as we saw in the game manager, when the drop method is called, we increment the number of cards in the drop zone and we emit the signal that card was dropped, so then the client can let the server know and the server can let the other client know that a card was dropped. This is what I was talking about, like decoupling. So here I've actually, like, I'm directly calling drop versus via the game manager, which may not be the best decouply way to do things. You might want to emit a signal instead, but whatever, this is the easiest thing, so just kind of roll with it. And absolutely finally, if it doesn't, if it is not over the drop zone, if it's not colliding with the drop zone, just return the card to its original start position. You may want to handle it differently. Like in some games, you could just put a card anywhere. But in a game like, I don't know, Magic the Gathering or Hearthstone, usually you have to drag and drop the card to a specific place. And if you don't do that correctly, or if it's not your turn, or if it's not the right time or whatever, or you don't put the right card in the right place, you just want to return it from whence it came. So that's it. This is I know there's kind of a lot here, but it's a very basic template for using Colyseus and Godot to make a 2D multiplayer card game. You could also use this for tabletop template, and like I mentioned, there are several other templates that I've included in the repo that you can go and check out, and I hope it's useful for you. If it is, please be sure to like this video and subscribe for more, and we'll see you soon.